Alright, hey guys, we are going to kind of go over section 6.1, which I just want to touch base on kind of organizing our thoughts. So I'll start off with the joke that I came up with on the spot. So all these things are polynomials. So if you have degree 0, you have this, where it's just a constant, any sort of number, and I'll show you why in a second. Linear is where there's the x to the first power, quadratic degree 2, cubic degree 3, quartic degree 4, quintic degree 5. And then for all of these polynomials, I think the most important type is, you guys like to call them crinomials, right? So it just makes you cry. So there's my joke. Yeah, so anyways, let's go into what I want to organize my thoughts into. So I think this covers a good amount of what I want from this section, which is if I take this and I change it to standard form, and what I mean by standard form is I list it out in terms in order of degree. So I put the leading degree in front. So I'll say something like negative, well, let's go ahead and add these two things together. So we'll start off with the first step, which is this becomes 2x to the 5th plus 11x squared minus 10, and now I need to distribute the negative, so it becomes negative 2x to the 6th, and then it's going to be minus 5x. So now I can just combine like terms, and that's just going to be, well, I want to make sure I have the degree in front, the strongest degree in front, and I see that x to the 6th is the strongest degree, so I'm going to take that term and move it in front. And then I'm going to take the next term, which is a positive 2x to the 5th. I see that I have an x squared term, so plus 11x squared. And then I have a plus 5x and a negative 10. Now, interestingly enough, nothing had to be combined here. If we did have to combine something, well, after we listed it out in terms of the degrees of each term, where we went 6, 5, 2, this is degree 1, this is degree 0, then we could combine it. Like if there's 11x squares plus 5x squares, then you'd have 16x squares. So ultimately, this is how you want to put it into standard form. So this is our standard form. Alright, now if we're talking about degrees, sometimes I might say something like, oh, we want to list them in order of degrees. And I'm just talking about each term. But when you're talking about a degree of a polynomial, which is what we typically want, the degree of the polynomials, whichever one's the strongest. And in this case, we see that x to the 6th is the strongest. So the degree of this polynomial, aka this is a polynomial of order, so the degree of this polynomial is 6, aka this is a polynomial of order 6. So I'll write it like this, polynomial. Degree of this polynomial is 6, also known as the polynomial of order 6. That looks better. Alright, the leading coefficient is whatever's next to the strongest, the term with the strongest degree. So we see that the 6 has the strongest degree here, for here, and the leading coefficient for it is the negative 2. And you can think of it as a couple different ways. Sometimes you think of it as whatever is right next to the term with the strongest degree. Or when you put it in standard form, the leading coefficient is going to be right in the lead, right? Because once you put it in strongest degrees, this will be right in front. So the leading coefficient is negative 2. Okay. Alright. The name of the polynomial. No, it's not a trinomial. So the name of the polynomial is this. We can go ahead and pull it up. And we can either pull it up from the book, which tells us that anything with the x to the, well, in this case we had a x to the 6. So we don't have a degree 6 here. So let's go ahead and look. I pulled up Wikipedia. Anything degree 6 is a sextic, or less commonly known as a hexic. So we'll say sextic. Alright, so this is a sextic polynomial. Sextic polynomial. And and that's the name of the polynomial. Is this an even or odd degree? Well, the degree of this, the degree of this thing is 6. So that means it is an even degree. And that's because it's 6. 6 is even. Okay. Leading coefficient, positive or negative. Well, we look at it and we say the leading coefficient is a negative, so we know that it's negative. So this gives us a lot of things, and this is what I really want to touch base on, is that we've answered these questions and we can do this. And I just remember my other joke. It was that a monomial looks to the other guy and says, "Hey, looks like you're running a fever." And he says, "Why is that?" And he says, "Well, it looks like your degree is really high." Right, so yeah, bad math jokes. Anyway, so leading coefficient is negative. Let's go ahead and plug this into Desmos and see what this looks like. So this is what I really care about, is that later on in the section, this chapter, they actually go over this sort of thing, but for now I want you guys to really kind of open your mind to this idea, how this thing works. So I'm launching Desmos to just give us an example to look at. So let's look at the one that we made. Negative 2x to the 6, blah blah blah. So let's plug that in. This is not in the powers I want. This is also not in the power I want. This is not in the power I want. I'm going to put f of x equals. Alright, now we can take guesses about how this is going to look, right? Because it's an even degree function, we know that the ends are always either going to look like this, or like this. So it's either going to look like this or this. That's when it's an even degree. The ends are always going to look like this or like this. The other thing is, because it's a negative, we see that's a negative leading coefficient. We know that it's not going to end like this. Just like in the parabola, if it's a leading negative for A in standard form, it's not going to open up. It's going to open down. So we know that it's coming down like this. So let's zoom out. And was I right? Yeah, it looks like it is. So the farther I zoom out, I can see that it still continues to open down, right? And that's the main part that I want you guys to see. So here's another thing. What if I change this and I got rid of some of this stuff in the middle? Did that change it a little bit, like the inside stuff, the behavior in there? Let's go ahead and get rid of more stuff. Okay, it's still opening down. Let's get rid of that. So all those little extra things, they control like stuff that's close to 0. But as we approach farther away from 0, like as we approach into x equals 1,000,000 or x equals negative 1,000,000, that sort of thing, like those middle parts become insignificant. And that's why you can tell that, because it's an even degree, it's going to open like this, or it's going to open like this. Is it going to go up or down? Well, that depends if it's a negative attached to that highest degree. Right, the other thing is this. If I have something like this, let's do f of x is equal to x to the third power. Well, x to the third power is an odd degree, right? And because this is an odd degree, if I had something like a positive number to a third degree, it's going to give me positive. If I have a negative degree, it's going to give me a negative. Now watch as I multiply by a negative number. And just for fun, I'm going to do like negative 2 times x to the third power. See how the green one is opposite. It flipped it. So instead of going like this, it went like this. Okay. So when we come back to class on Tuesday, we're gonna dance around a little bit. I'm gonna force you guys to dance. I'll put on some music and stuff, and we'll dance out our even, odds, and different leading coefficients. All right. So this is really what I wanted to touch base with. Is you can figure out what a function should look like on a graph, depending on what its degree is and what its leading coefficient is. It tells you a lot about the function. Last thing, evaluate f of n for n equals 2, for f of n equals 2n squared plus 3n. All you have to do is plug in n equals 2, so f of 2, so the function at 2 is equal to 2n, well n is 2, and we're going to square that, plus 3 times 2. That gives me f of 2 is equal to 2 times 4 plus 6. That gives me f of 2 equals 8 plus 6. F of 2 equals 14. Okay, so that's how I would do this one, right? And I want you guys to kind of like write these things in. We're gonna talk more about like the concept stuff. I think for Chan Academy stuff, I'm gonna still try to do procedure stuff, but judging from how our tests went, like we really want to focus on conceptually, like do we understand what the point is? Because I could have you guys label this like no problem and tell you, okay, I want you to figure out from this chart what degree polynomial is it, what's the name of the polynomial. But that kind of stuff like doesn't test anything. It just tests whether or not you can remember. But if you can figure out, you know, because I have an even degree, well, no matter what I plug in, negative or positive, it's not going to make a difference. It's going to still get me the same number. That's why it's opening like this, right? Like if I have positive a million or negative a million, or opening down, where they'll still give me the same value. That's the thing that's important to me. So in that case, have a good weekend. I'll see you guys on Tuesday, and we'll get back to work.